Hello everyone. So today we will be solving this restaurant customer problem from CSES. Now the problem speaks about you are you are given the arrival and leaving times of n customers in a restaurant. What was the maximum number of customers in the restaurant at any time? Okay, so what do we have is looking at the input. So it says 3, 5, 8, 2, 4, 3, 9. So we have been given the intervals in where one customer arrived. So like between let's say from 5 p.m. to 8 p.m. one customer arrived, from 2 p.m. to 4 p.m. and another customer arrived, or 3 p.m. to 9 p.m. another customer arrived. So it's like he came at 5, then he left the restaurant at 8. So now they are saying like let's first plot this. Okay. So 2, 4, no, 3, 4, 5, 8, 9. So 2 to 4, one customer arrived, arrived at 2, left at 4. Then at 3, another customer arrived and left at 9. And another customer arrived within 3 and 9, that is 5 and 8. Now, if you just look at the number line that I have plotted here, now it's something like we are starting from 1, okay? Then on 3, another customer arrived. So plus 1, so 2. Then at 4, a customer left. So total number of customer will be 1 here again. Now at 5, another customer arrived. So we will increment this 1 to again 2. Then he left at 8. So again 1 minus 1. Then at 9, the last customer left. So we are back to 0. Now in this like running customer count, we just have to return the maximum number of customer we had at any given time. So for this the answer is 2. Now I guess from this only we can easily figure out like how we can code it. So it's simply like we have been given the intervals. If we simply short the intervals, or not even short, for every arrival time we do a plus 1, and for every leaving time we do a minus 1, then we can easily get the running count of customer, right? So simply like summation of this plus 1 and minus 1. And if we store a simply max count, that will always compare, like whenever we are doing an operation on running count, so max count will store the maximum value of running count at any instant, then max count will be our answer. So just like this, so this represents my running count. Now if I have a max count, if we start off with 0, and for every operation that I do with like every update operation that I do with running count, if I simply compare at that instance, hey, whether that value is more than max 1, more than max count, then in the end my max count will be storing 2, and I can simply return 2 as my answer. So that's the gist of the problem, and the way to solve it. Now time complexity wise, if you say, so we have like 5, 8, 2, 4, 3, 9. So they will be giving in this order. Now what we can do is we can store this intervals not as interval but as individual components. So by individual component, what I mean, like whenever we will be given 5 and 8, we can store it something like 5. So this is like 5 value, and for 8 it will be like minus 1 value. Minus 1 because like somebody is leaving at 8, right? So yeah, so we will be getting something like this. And similarly for 2 and 4, uh, 2 will be having 1, 4 will be having -1. Then similarly for 3 and 9. Okay. Now, so we have all the time and their value. Then we simply sort them with respect to the first value. So that is what I have done earlier in this pictorial representation. So all of them are like sorted with the first value here. And in the running count, I will simply update it by using their second value, which is this. So yeah, with this I will be updating running count, and with that I will be comparing max count with the current running count, and in the end I will be storing the maximum number of customers. Now, time complexity wise, like this will be a linear traversal, the running count updation. Okay, but let's do it properly. Okay, this will be linear, the running count, but before that I have to take the input and sort them, right? So taking input will be order of n, but sorting them will be in the order of n log n. So overall time complexity will be big O of n log n. Cool. Now let's quickly code this up. So first they are giving the number of intervals, so n. Okay. Then the actual intervals. So intervals. So we'll be storing pairs. So I pair is a macro of mine, so which basically represents you can see like pair of ints and ints. Okay. Now this is intervals. Now let's quickly take this input. And I will be pushing back for A. I will store 1, and for B I will be storing -1. Cool. Now we have to sort with respect to the first element. Now in sorting in C++, if we have pair, it inherently compares all the elements with respect to first value. Now if the first values are same, then it compares with respect to the second value. So we don't need to write any lambda function in that sorting function. So we can simply do intervals like the general syntax for sorting. Now sorting will automatically take care of like for any A and B, it will first compare the first element. B first. Okay. If they are different, it will automatically compare this two. Now, if they are same, then it will compare the second one. Cool. Now, here is our running count. And our answer, let's say instead of max, we can do answer. Cool. Now, let's traverse our list. I can do for auto element in intervals. Yeah. So running count, as I said, I will be updating with LE of second value, and my answer will store the maximum value at any instance. And I can simply print my answer. Cool. So I have already taken this input. Let's run this. I got 2 and answer is 2. Now let's quickly submit this. Cool. All got accepted. So I've already done this, but just for the sake of writing it again. So the time complexity wise, so input taking we generally don't take like count that in time complexity. So from here we'll be doing our time complexity analysis. So yeah, So sorting takes n log n. Okay. So more precisely, like for every interval, we are pushing it two times, right? So we will be getting two times n elements. So two times n. Okay. Now the log of will be like the size two times n. Okay. Which is similar to like which is same as doing an n log n. So and then we have this intervals. So this will be 2 times n. So 2 times n is basically the size. Now if we simply look at the order, so it's same as n log n plus big O of n. Now first time complexity, like this n log n will dominate over our linear time complexity, so it's a n log n approach. Cool. Now space complexity wise, so we are only using these intervals for storing our input, so we will not count that as our space time complexity, like we will not count it. Now like if we don't consider this, so nowhere we are using any extra space for computation, all of them are variable. So let's say we go off one, so constant space we are using. So cool. So these are the time and space complexity, and I hope you learned something new. So just stay tuned to watch more videos.